Friends, welcome to Karna Maths Academy. Today in this lecture, we are going to discuss exam question answers, HSEB NEB 2064, question number 13, Group B. Question number 13, examine the function fx is equal to x cube minus 6x plus 10 is increasing or decreasing at x is equal to 2. Also find the stationary points and the point of inflection, if any. Examine the function fx 2x cube minus 6x plus 10 is increasing or decreasing at x is equal to 2. Also find the stationary points at the point of stationary points and the point of inflection, if any. Solution. In this question, we are given a function fx is equal to x cube minus 6x plus 10, and we have determined whether the function is increasing or decreasing at the given point x is equal to 2. Then next, we have to find the stationary points and the point of inflection. Fx is equal to 2x cube minus 6x plus 10. The given function is fx is equal to x cube minus 6x plus 10. Now to determine the function is increasing or decreasing at the given point x is equal to 2, we take the help of the first derivative. If the first derivative, that means f dash x, if the first derivative of any function, that means f dash x, is positive at the given point, then the function is increasing. And if the value of the first derivative is the value of the first derivative of given function is negative at the given point, then the given function is decreasing. So let's find out the first derivative. So first derivative will help us to determine whether the function is increasing or decreasing, and with the help of first derivative we can find the stationary point, and to find the point of inflection we have to find the second derivative. So let's find first derivative of the given function. So first derivative of fx we can denote by f dash x is equal to dy dx of 2x cube minus 6x plus 10. Derivative of the function fx with respect to x, dy dx of 2x cube minus 6x plus 10 is equal to dy dx of 2x cube minus dy dx of 6x dy dx of plus 10, because there are three terms. So applying the sum rule of derivative. Now dy dx of 2x cube, derivative of x cube is 3x square. The coefficient is 2, so coefficient we keep as it is. Derivative of x cube is 3x square. According to the power rule of derivative, the derivative of xn is equal to nxn minus 1. That means we have to write down power at first and decrease the power by 1. So 3 minus 1 we get 2. So x cube derivative is 3x square, n x n minus 1 plus. Then second term is minus dy dx of 6x. The derivative of x is 1. Again applying the power rule, xn means nxn minus 1. That means we have to write power at first and decrease the power by 1. So 1 minus 1 0. That means x power 0 means 1. 6 is coefficient as it is. X derivative is 1. So derivative of 6x means 6 into 1 plus derivative of constant, that means 10. Derivative of any constant is equal to 0. Dy dx of 10 is equal to 0. Let's do the calculation now. 2 into 3, 6. 2 3 is 6x square minus 6. Now when x is equal to, so we have already got the first derivative. Now we have to show the function is increasing or decreasing at the given point x is equal to. So we have to substitute. We have to find the value of first derivative at the point x is equal to. If the value of first derivative at the point x is equal to is positive, then the function is increasing. And if the value of the first derivative at the given point, that means x is equal to is negative, then the function will be decreasing. So let's put the value of x is equal to in the first derivative. That means let's find the value of the first derivative at the given point x is equal to 2. So let's put x value 2 on the left hand side and right hand side. F dash x value 2 is equal to 6 into x value 2. 2 is square minus 6 as it is. So 6 into 2 to the 4. 4 6 are 24 minus 6. So 24 minus 6 we get 18. That means the value of the first derivative at x is equal to 2. That means f dash 2 is equal to 18, which is positive number. That means greater than 0. It shows that the given function fx is increasing at the given point x is equal to 2. When the value of first derivative is positive, then the function is said to be increasing at the given point. Now for a stationary point, next we have to find the stationary point and the point of inflection. A stationary point we can find with the help of first derivative. If the value of first derivative is equal to 0, at any point if the first derivative is equal to 0, then the point is called a stationary point. That means to find the stationary point, which is also known as critical point, we have to suppose first derivative is equal to 0. If first derivative is 0, if the value of the first derivative of any function is 0, then the point is said to be a stationary point. To find the stationary point, we have to suppose first derivative equals to 0. First derivative is equal to 6x square minus x. 6x square minus 6 is equal to 0. 6x square is equal to 6. That means 6 is cancelled. X square is equal to 1. X is equal to plus minus 1. That means stationary point is equal to plus minus 1. That means at x is equal to 1, the value of first derivative is 0, and at x is equal to minus 1, the value of first derivative is equal to 0. That means plus minus 1 are the two stationary point of the given function fx. The two stationary point of the function fx is equal to x cube minus 6s plus 10 are plus minus 1. Next we have to find the point of inflection of the given function fx is equal to x cube minus 6s plus 10. To find the point of inflection, we have to take second derivative is equal to 0. The point where the value of second derivative is equal to 0 is said to be point of inflection. So let's find out second derivative of the given function. The given function is fx is equal to 2x cube minus 6x plus 10. First derivative we can denote by f dash x. First derivative is equal to 2 as it is. Derivative of x cube is 3x square minus 6 as it is. The derivative of x is 1. The derivative of constant is 0. That means derivative of 10 is 0. Therefore, first derivative, that means f dash x is equal to 3 to the 6x square minus 6. Now we find second derivative because we have to find the point of inflection. The second derivative of function is dy dx of the derivative of first derivative. The derivative of derivative is called second derivative. So to find second derivative of the function, we have to find the derivative of the first derivative function. That means dy dx of 6x square minus 6. 6x square minus 6 is the first derivative of the given function. So let's find out the derivative of f dash x to get the second derivative is equal to dy dx of 6x square first term minus dy dx of 6 second term. 6 as it is, 6 is the coefficient, x square derivative is 2x minus the derivative of constant is 0, 6 to the 12x. So second derivative of the given function f double dash x is equal to 12x. Now for the point of inflection, the point where the second derivative is equal to 0 is said to be point of inflection. So let's suppose second derivative is equal to 0. Supposing the second derivative is equal to 0, the value of second derivative we have already found 12x. So 12x is equal to 0, x is equal to 0 by 12. That means the value of x is equal to 0. Therefore, the point of inflection of the given function is x is equal to 0. Hence the point of inflection of the given function fx is equal to x cube minus 6 plus 10 is equal to the point of inflection of the given function is x is equal to 0. Thank you. Thanks for watching this video. If you like this video, please subscribe my YouTube channel Karna Maths Academy and share it to your friends. And don't forget to hit the notification bell icon so that you will get the daily updates of class 11 and class 12 math solution of the important questions with basic concept. Thank you. Thank you very much. Thanks for watching this video.